So in this lesson, we're going to be combining some of our previous ideas. So if you guys remember a few units back, we talked about graphing inequalities. We said which way that meant our arrow would point on the number line. Now we're going to combine that with actual graphing and talk about where that means our answer will lie on a coordinate grid. Okay, so first thing they ask is to recall that inequalities with one variable can be plotted on a number line like x is greater than or equal to 2. So if you guys remember, what we did when we were given something like this is we would go to the point where 2 was, and we would make a point, right? Then we had to decide if that point should be an open circle or a filled in. Anybody remember how we decided that? Right. If it has that equal to sign with it, we know we want to include it, so we fill it in. Okay. And this says that x has to be greater than 2. Well, do things get greater when we go to the left or to the right? That's where my numbers get bigger. So I would draw an arrow going off this direction. And remember, it should match the direction of our inequality. Right? All right. So then it says the solution to an inequality is a point which, when substituted in for the variable or multiple variables, make the inequality a true statement. So then they ask, which of the points on this line fall in our solution? So our solution starts at 2, which is C, right, and goes this direction. So does A fall inside of that? What about B? Right, B is on this side too. C is right where it's at, and we filled it in, right? So C should be part of it. If it was an open circle, C wouldn't be part of it, right? And then we also include the D and the E because our arrow says that line's going to go on forever, so it will go past E and E. All right. So now we're going to compare that to something that we would see on an actual coordinate grid. And it says inequalities with 2 variables have to be plotted on a grid like this, right? You have a Y and you have an X. So that's why it has to go on a 2-dimensional coordinate grid like this. It says that they plotted the equation of the line y is greater than or equal to x. So first what they did was they pretended this was just the equation y equals x, right? There was no plus b, so they started at 0, and their slope told them to go up 1 over 1, up 1 over 1, right? So that's how they came up with this line. But then they went back and read it, and it said that y had to be greater than x. So y has to be greater than this line, right? So if this is the line, things are greater when you're on top of it, not when you're underneath the line, right? So that's why they shaded everything above that line, okay? So what letters fall in our shaded region, or what coordinate points fall in the shaded region here? Right. As well as our point B, because it's on the line, right? And it did have the equal to sign with it. So anything on your line will also be included. So when it asks what points are part of our solution, we would say the points A, B, and C. All 3 of them fall in the shaded region. Okay. We are only allowed to include B because, like I said, there was that equal to sign. If they hadn't, we wouldn't include anything that falls right on the line. Okay? All right, so let's flip it over onto the back. It says that if you want to graph 2 variable inequalities, so equations of lines, then you have to use the following steps. It says if it's not already solved for y, then you need to do that. That just means you need it to be in y equals mx plus b form before you can graph it. If it's not that way, we're going to rearrange to get it there. Okay? After we do that, we graph this part over here just like we normally would. B tells us where to start. our m, or our slope, tells us how much up and over we're going to go for every single point. Okay. Now this is where the inequality comes into play. Okay. If you have a solid line, that means you must have had an inequality with the equal to sign. If your inequality does not have an equal to sign, like one of these, the line that you use to connect all your points is going to be a dotted line, because we don't want to actually include the line, just everything above or below it. If you are supposed to be shading below your line, what I mean by above and below is like what they had here, they shaded above the line. If you're supposed to shade below, then your equation had to have had the less than symbol. If you shade above, your equation needed to have the greater than symbol. So we'll reference these up here at the top as we're graphing to make sure we do it correctly. So on number 1, is this in y equals mx plus b form?
Yes.
Yes. So we're good there. We don't have to do any rearranging. They want us to identify over here these items. So what is our m, or our slope? Perfect. And what is our b? Right. And then they have d or s. So they want us to choose if our line should be dotted or solid. So remember, to choose that, you look at whether it has the line or not. This one should be solid, right? Because it has the equal to with it. So we're going to make a solid line. Then A or B stands for above or below. So that depends on which way it faces. This says Y wants to be less. So yes, we would want it to be below. And you can look right here, right? It faces the same way as this one. All right, so now we're going to actually go in and graph that. So does the -2 or -3 tell us where to start? Right. So I'm going to come down here to -3, plot my y-intercept. If my slope is -2, how much are we moving for each point? Very good. Okay, and we circled S, so we're going to connect all of those points with a solid line, like we normally would. And we said that we're going to shade everything that is below that line. So since our line slants this way, below would be everything over here. All right. Okay, let's do another one. Okay, number 2. Is this one in y equals mx plus b form? Yes. Yeah, so no need to rearrange. What is our m, or our slope? Right, part with x, very good. What's our b? Good. Okay, here's my inequality. Are we going to have a dotted or solid line? Dotted. And the way that's facing, are we shading above or below? Above this time. Okay, so we come over here and we graph it. Where does this one start at? Good. And how much up and over are we going to go? Very good. Okay, now before we go connect our lines, Alan, before we go connect our lines, what are we going to be connecting them with this time? A dotted line. So it needs to be dashed. Okay, and where did we say we wanted to shade this time? Above. So everything that is above that line is where I'm going to shade. So all of this area up here is where we shade. So any point that would fall where we just shaded would be part of our solution. Okay. All right, number 3, is that one in y equals mx plus b form? Yes, so we're good there. What's our m? Nice. And what's our b? Good. Okay, looking at that inequality, are we dotted or solid? Good. And we shading above or below? Nice. So b tells us where to start. So I'm going to start at, good. And we go up and over how much? And now when we go connect those points, we connect them with a right. And we said we're going to shade above, so everything that falls above that line. Okay, last one, are we in y equals mx plus b form? Yeah. Okay, so what's our m? Negative 2/3, very good. Okay, what's b? And we want a dotted or solid line. Good. And are we going to shade above or below? Below this time. Okay, so this tells us where to start. So we go up there and we plot our first point. And how much up and over or down and over are we going to go? Good. And we are connecting this one with a right. Below, so we're going to shade everything underneath